students, in this video we are going to learn is about preparation of alcohol. Okay, and there are so many preparation of alcohol which is under reducer levels that we are going to learn one by one, and it is very important. So first we will see is the preparation of alcohol from alkene, and there are three ways to prepare alcohol from alkene. Number one, by direct hydration, number two, by indirect hydration, and number three, by hydroboration-oxidation. So these are the three methods to prepare alcohol from alkene. So let us go with the first method today. How to prepare alcohol by direct hydration. Hydration means to add water. So ethene formula is CH2 double bond CH2, to remember. Now hydration means to add water, so we are adding it directly, so direct hydration. And the catalyst used for this is dilute sulfuric acid, and instead of dilute sulfuric acid you can see simply H+. Now when you do so, we break down this H and OH, okay, into two halves, that is H and OH. Water can be broken down as H2O, so we broke it as H and OH. Now here what we do is we break double bond into single bond. Okay, double bond, we will break it into single bond. So here was CH3 CH2 double bond, here is CH2 CH2, but double bond I made it single bond. Now in water, do remember H is positive and Br is negative. Now where should I take H and OH? Where should I take H? Here. Then OH has to be taken here. If I take H here, I have to take OH here. Okay. Now here what you have to remember is between the double bond carbon atom, hydrogen number is equal. Between the double bond carbon number, hydrogen number is equal. So if hydrogen number is equal, we call symmetrical alkene. So if between the double bond carbon, if the hydrogen number is equal, we call symmetrical alkene. So this is the example of symmetrical alkene. Now to that you are adding water using dilute sulfuric acid or H+ as the medium, acidic medium we consider it as. So since it is symmetrical alkene, so you can take H, OH wherever you like. So I'll take H here and OH here. I can take wherever you like. Okay. So I could have taken H here, OH here, same thing, or you can take H here, OH here, same thing. So you don't have to follow any rule. If it is symmetrical alkene, you can take H, OH anywhere. So if I take this H out here, CH2 will become CH3, and similarly if I take OH here, so it will come OH here, whereby I'll get ethyl alcohol. So this is the preparation of ethyl alcohol, which is a primary alcohol because OH is linked with CH2. Now second one, now let us see how to prepare through direct hydration using the same catalyst or medium, you can say, with propene. Prop means 3 carbon, you know that, and ENE means double bond. So when you make double bond, you make it from the back, other will be single bond. Now make the valency of carbon 4 by adding hydrogen. So 1 2 3 4, 1 2 3 4, 1 3 4. I added hydrogen. Okay, so this became propene. Now again you are doing hydration. H and OH, water means HOH, H is positive, OH is negative. Now where should I take H and OH? Now if you see here, double bond adjacent carbon does not have same number of hydrogen. Here is 1, here is 2. So it is unequal number. Here it was equal, so I call symmetrical. But here it is unequal. H is 1 here, 2 is this side between the double bond. Therefore it is called unsymmetrical alkene. So when you add reagent to an unsymmetrical alkene, you cannot take HOH wherever you like. So that time we have to follow one rule known by the name Markovnich's rule. We have to follow a rule known by the name Markovnich's rule. And this Markovnich's rule states that negative part will go to that carbon of the double bond which has less hydrogen, and positive will go to the one which has more hydrogen. I repeat again. So if it is symmetrical alkene, HOH you can take wherever you like. But if it is unsymmetrical alkene, you have to follow a rule known by the name Markovnich's rule. According to the rule, negative part should be taken to that carbon of the double bond which has less hydrogen. So I am going to take the negative part here because hydrogen is less, and positive to the one which has more hydrogen, and I am going to take here. So first of all, I will break double bond into single bond. You can see here I broke double bond into single bond. Double bond is been broken down into single bond, CH3 CH, CH2 CH3 CH, CH2. Now here the negative part will go, means here OH will go, and H will go here, means CH2 will become CH3. And if you see here, what I got is isopropyl alcohol. CH3OH, which I said in my first video, isopropyl alcohol. And if you see here, OH is linked with CH, so therefore it is secondary alcohol. OH is linked with CH, so it is secondary alcohol. Therefore, it is also known by the name sec-propyl alcohol, whose IUPAC name is propane all in number 2. So it is called propanol to the IUPAC name. So we prepare primary alcohol as well as secondary alcohol through direct hydration. Now again, I am taking propene. Since I made you understand the formulas, I am writing here directly the formula of propene. Now again, I am doing hydration, means reacting with water in acidic medium. Now again, water can be written as HOH, and as you know, this is unsymmetrical alkene, as I have said here, because carbon bonded with double bond has not equal number of hydrogen. They don't have equal number of hydrogens. It is unsymmetrical. So we have to follow Markovnic rule. Negative will go to the less hydrogen containing carbon, and positive will go to the more hydrogen containing carbon between the double bonds. But if I do so, I'll get the same result the way I got here, isn't it? I'll get the same result the way I got here. So therefore, here I am going to use a catalyst called peroxide. So when I use peroxide, the Markovnic rule become opposite, and it will become anti-Markovnic rule. Markovnic rule become opposite, and it becomes anti-Markovnic's rule. It becomes anti-Markovnic's rule. It becomes anti-Markovnic rule when you add peroxide. Here I didn't add peroxide, so it is Markovnic. But when you add peroxide, it becomes anti-Markovnic. So in Markovnic, negative was going to the less and positive was going to the more. But in anti, it will become opposite. Now, negative will go to the more and positive will go to the less, whereby you get different product. Let us see what we get. First, you write the same CH3, CH, CH2. I wrote the same thing as what is here. Now, negative will go to the more, break the double bond into single bond and take negative to the more, and positive will go to the less. So if this H is added here, it will become CH2. And this compound is known by the name propyl alcohol. It is known by the name propyl alcohol. Okay, what we call it by the name propyl alcohol. CH2, 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 propyl alcohol. And it is a 1 degree alcohol because OH is linked with CH2. So see the difference in these two. In propene, if you do direct hydration with using Markovnic rule, negative will go to the less, positive will go to the more, you get secondary alcohol. But if you use peroxide, it becomes anti-Markovnic, negative will go to the more, positive will go to the less, and it becomes primary alcohol. Okay, so far through direct hydration I prepare primary and secondary alcohol to you. But do remember, you can even prepare tertiary alcohol, but that is not required. So I am not explaining about the tertiary alcohol preparation. Just go right now with only primary and secondary. For tertiary alcohol, we'll prepare by some other reactions. For direct hydration, just remember primary and secondary. So if you want, you can take the screenshot of this. Now we'll see indirect hydration, students. So eth means how many carbon? 2 carbon. ENE means double bond. Carbon valence has to be 4. 1, 2, 3, 4. 1, 2, 3, 4. To make 4, you add hydrogen. So this is your ethene. So in indirect hydration, we react with concentrated sulfuric acid, H2SO4. And this sulfuric acid can be broken out down this way: H plus HSO4 minus H2SO4, in which H is plus, HSO4 is minus. Now again here double bond, you break it into single bond. This double bond will become single bond and it is symmetrical. So no need to use Markovnic rule here because hydrogen number is same. You can take anywhere. So I'll take H here and this portion out here. So when I do so, as this H goes here, it becomes CH3, single bond. Then in this CH2, this HSO4 will go. So we got this compound. It is indirect hydration. Okay. Now we are going to boil it with water. So when you boil with water, water can be written as HOH. So this portion will take H and form sulfuric acid back, H2SO4, which is here. And in place of this OH will enter here to form ethyl alcohol, which is a primary alcohol. So you all understood. Now for the propene, if I do the indirect hydration, see what happens. Prop means how many carbon? 3. ENE, we always make from back, double bond, other will be single. Make the valency of carbon 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 3, 4. To make 4, you add hydrogen. Now again, you are reacting with sulfuric acid. Now this is H plus and HSO4 from sulfuric acid. But if you see double bond, adjacent carbon, they don't have same number of hydrogens. So it is again unsymmetrical. So if it is unsymmetrical, we have to follow which rule? Markovnic rule. MR means Markovnic rule. So when you apply Marconi rule, negative will go to the less carbon containing hydrogen, and positive will go to the more hydrogen containing carbon. As a result, this CH3 will remain CH3, CH will remain CH, okay? CH3 will remain CH3, CH will remain CH. Now if this H goes here, it will become CH3, and this one will go to the H and it can be written this way, HSO4, HSO4, same thing, HSO4, HSO4. But why are we written like this? Because carbon will be linked with oxygen. Now again, like before, you put water and burn, and water means HOH. So this portion again will take H and forms H2SO4. Sulfuric acid will come out. This is called indirect hydration. This is your H. We will take this one to form sulfuric acid. In place of this, OH will come, and we get like this, and this is called isopropyl alcohol, 6-propyl alcohol, or propanol 2, which is secondary alcohol. So far I have taught you how to prepare alcohol through direct hydration, through alkene, using hydrolysis in dilute HCl medium, sulfuric acid medium, indirect hydrolysis with the help of sulfuric acid, and we are taking in concentrated form. Okay, now we go with number 3 method, how to prepare again alcohol by hydroboration oxidation reaction. Now let us go with this, students. Okay, this is the general formula of alkene, students. You can see carbon-carbon is linked with double bond, so it's alkene. If you see here, CH is CH, CH2 is CH2, just I replace this CH3 with R in the general form. Now you react with boron. Boron formula is BH3. Boron formula is BH3, in which H is the negative part, BH2 is the positive part. So again, you break double bond into single bond. CH, R is here, CH is here, CH2 is here. So break double bond into single bond. And in this, we use medium as tetrahydrofuran. THF means tetrahydrofuran. Okay, it's tetrahydrofuran, which is a solvent, which acts as a solvent here, and boron formula is BH3, in which H is negative, BH2 is positive. Now again, if you see here, double bond adjacent carbon does not have same number of hydrogen, means it is unsymmetrical, so you have to use Marconi rule here also. MR means Marconi rule. I'm going to apply here. So negative will go to the less hydrogen containing carbon, and positive will go to the more. So if this H will go here, it will become CH2, and if this BH2 will come here, it will become CH2, BH2, and this compound is called alkyl boron. Now to this alkyl boron, you repeat one more alkene group, the same alkene group which is used here, you will use it one more time. So when you use it one more time, then this R, okay, CH2 will become 2 times, because you are adding one more to this. So now all of a sudden this 1H will combine out here. So you take 1H from here and give it to it. It will become RCH2CH2, and here is also RCH2CH2 2 times. Then what if you give 1H here, it will be BH, which is here, and this is called dialkyl. This is called alkyl, okay, dialkyl boron. Now you use one more time, because one more H is here. So this H, put it out here again. So you get RCH2CH2. So RCH2CH2 it was 2 times. If you take this H here and you make it RCH2CH2, it become 3 times. So now RCH2CH2 will become 3 times, and what will be left here? Only B. And this is called trialkyl boron. We call it trialkyl boron, students. So hope so you all understood till here how to go with the reaction. You can repeat if you want, but A and B is more important than C. We are doing it for the sake of syllabus, but A and B is more important than C. Now this trialkyl boron is here now. Now there is no more H left with this. When here was 2H, I reacted with one more alkene. When here was 1H, I reacted with one more alkene. Now here is no more H left. All the H from triboron is been removed. Trialkyl boron. So it's a continuation. So I have finished till here, till triboron. Now in the second step, the same triboron which you obtain here in the second step is reacted with hydrogen peroxide in alkaline medium. H plus means acidic medium, OH minus means alkaline medium. Now you can see here H2O2 is 3 times. So you write 3OH, 3OH. It means 3H, 3H. Total 6. 3O, 3O means total 6. I am breaking 3H2O2 in this form, 3OH, 3OH. So when you do so, this will take 3OH to form BOH whole 3, BOH whole 3 from hydrogen peroxide, and this is called boric acid. Whereas this portion is 3, you can see R CH2CH2 is 3 times, I wrote here 3 times R CH2CH2, 3 times R CH2CH2, 3 times R CH2CH2, and this 3OH is left, put out there, and you get alcohol. So this is how we prepare alcohol from alkene by hydroboration-oxidation reaction in this much state. So you can repeat the video to understand. Now students, we will see one particular example of hydroboration-oxidation reaction. So I am replacing R with CH3. So when you replace R of CH3, then it becomes propane. And you are reacting with boron, whose formula is BH3. This is called hydroboration. Solvent uses tetrahydrofuran. So when you take it 3 times, this 3H, okay, you have to take this 3 times. So if you take this 3 times, then one H will go here, the other H will go here, the other H will go here, and you get CH3, CH2, CH2 3 times. And here only B will be left. Now when you do a hydrolysis with hydrogen peroxide in alkaline medium, then you know that this hydrogen peroxide can be written as 3OH and 3OH, as I said earlier. It can be broken down into this way, in which this B will take this 3OH to form BOH3, and that is called boric acid. Then this 3 CH2CH2CH2, 3 CH2CH2CH2 will take the remaining 3OH, and you get is CH2CH2OH means 3-propyl alcohol. So this is the preparation through hydroboration-oxidation reaction. So by this we completed how to prepare alcohol from alkene by 3 ways: direct hydration, indirect, and hydroboration-oxidation, ABC, in which A and B is more important than C. But you have to learn because it is in the syllabus. Now we go with number 2, students. Number 2 is called by hydrolysis of alkyl halide. You know that Rx means alkyl halide. Now hydrolysis means here we do alkaline hydrolysis. Inside aqueous there is water, and this is alkali, so this is called alkaline hydrolysis with aqueous KOH. And we have seen this before also. The job of aqueous KOH in organic chemistry is to undergo substitution reaction, for which we saw 2 mechanisms, SN1, SN2. Okay, so this X will come out, go with K to form KX, and this OH will enter in to form ROH, which is alcohol. If you take here Cl, you get here KCl, Br, KBr, iodine, Ki. So this is how we get alcohol from alkyl halide. So let us take one particular example. R can be replaced with ethyl, CH2 means ethyl, X means bromide, so this is the name called ethyl bromide. You are doing alkaline hydrolysis with aqueous KOH. This K will take Br to form KBr, then this CH2 goes with OH to form ethyl alcohol. So this is how we prepare alcohol from alkyl halide by reacting with aqueous KOH. So we finished 2 preparation so far in this video. One from alkene by 3 process ABC, direct hydrolysis, hydration, indirect hydration, and hydroboration-oxidation, in which AB is important, and number 2 by hydrolysis of alkyl halide. So do remember this much preparation. So from number 3 preparation we do in our next video. Thank you.